Okay, we're going to extract. There's two things we're learning today. And I just thought about this too as second hour walked out the door. Make sure you look at your notes, and part of the homework is the one thing, and then the other parts are the other thing. One of the things we're going to learn today, I am going to extrapolate, and it's based off of what we learned the previous two sections, let's call it. Okay, now let's go say that word that one teacher throws stuff at you. What would I have to do with this? How many times? Four. Well, actually, it's three, right? You'd have to foil once, then again, then again. And I made a mistake. So I do, and I don't want to write this all out like last hour. You'd have to do this times this, get that answer, and then multiply that answer by this, and then multiply that answer by one more of those. Right? Wouldn't that be a lot? Wouldn't that be a pain? Yes, Mr. Thamberlith. Okay. So we're going to actually extrapolate an idea that's built off the previous ideas that we've learned. For instance, number one from section A2, let's make this a SIS number. So where do I go for 2 minus 2I root 3? Where do I go for 2? Right. Where do I go for negative 2I root 3? And it's just negative 2 root 3. I guess I wouldn't mark you wrong if you put 2I root 3 for the graph. But remember, this is the real axis. This is the I, or imaginary axis. That's why I go 2 root 3 down here. Hey, what's this? What's this? What is it, right before my eyes? See, last hour I said, no, that's not right. I go, then what is it? What is it? And I go, I don't know. So it is that. All right, good. Because I really like that movie. All right, so what's this right here? 4A, A root 3, 2A. A is 2. So this is 4 cis, and then let's do the angle measure from 0 to 360. What's the angle measure? 300. And now what I'm going to do is take this to the fourth power. And I'm going to use what does it mean to raise something to the fourth power? It means to take it and do what with it? So, but look at how this is going to work out. And then we're going to extrapolate a new formula, if you will. And it's actually very easy. Now we're going to take this and multiply it by itself 4 times. And then just use your multiplication rule. What am I supposed to do with these 4s? Multiply them. And then what am I supposed to do with this angle, with this angle, with this angle, and with this angle? But what's the same as adding 4 300s? Multiplying by what? 4. So this equals 4 to the fourth cis 4 times 300. And there's your rule. Whenever you take an I number raised to a power, you take the R to that power, and you multiply the angle by whatever that power is. And then I'm going to go back to that question and actually turn it into rectangular. So now back to this after showing that rule. What's 4 to the fourth? Because you guys help me out on that. 256, is that right? Cis, now the only thing we have to do is 1200 is on your calculator subtract out the 360s to find out where this lands. And then find out what it is as an angle measure. I think last hour got 120 maybe? Good. And then all you have to do is do the trig of 120, which is a 60. What's the side opposite 60? I shouldn't have to do this anymore. Side opposite 30. Side opposite 90. And then what's the cosine of this 1200, which is this 120 here? What's the cosine of this? Oh, sorry. Negative 1/2. What's the sine of this 120 or 1200? Root 3 over 2. I. And then all you have to do is distribute. What's half of 256? I'm embarrassing myself. I can't think. Negative 128 plus 128 root 3I. And actually, that's what you would have got if you would have foiled this 4 times. Foil, 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 foil. Okay, so the first one is nice. And then I'm going to tell you. Well, okay, I'll tell you in the next example. This one's easy. This is in SIS format, so you should want a million of these questions. If I raise this to the third power, what should I do with the 3? Or raise it to the third power, you're right. And then what should I do with the 40 degrees? Multiply it by 3, so that's 120. Now notice what it says. Write each answer in rectangular form. So now what I have to do is 27, right? And then we just had cosine of 120 and sine of 120. What's the cosine of 120? Negative 1 over 2, right? And what's the sine of 120? I, right? Cis I sine 120. And then distribute. And that's the answer. Okay, so that one, okay, great. Whatever. But then look at this one. Oh, how many times would you have to FOIL this one? 8. Are you kidding me? Actually, 7. You do realize they take 2 parentheses. That's one of them. Oh, and now I'm going to tell you to do this one to the 8th power is equal to the work for the 4th power one when we do the SIS thing. It's no harder. Okay, but what we got to do is graph it. Where do I go for root 2 over 2? Which direction? Right. Where do I go for negative root 2? Down. And I do want to label these. What's this? What's this? Ooh, that's a good one, isn't it? Anyone know? It's 1. Now, we could do the Pythagorean theorem, but those are those. Remember when I did the unit circle and I put the coordinates next to the angle measures? All right? That was from the unit circle. The cosine of 45 is root 2 over 2. That's when r equals 1. The sine of 45 is root 2 over 2 when r equals 1. Okay, so so you have 1 cis. What's the angle measure? Now, we did this last hour. There's one of 2 choices, and it is legal. 315 is legal. That's what we'd probably mostly write. But then what am I going to do with 315? What am I going to have to do with 315? Multiply it by 8. What's another option for 315? Negative 45 might be better because I'm going to have to multiply that by 8, and then I'll just have a smaller number. So it's 1 to the 8th. By the way, what's 1 to the 8th? Cis, what's 8 times negative 45? Someone do that for me. Are you serious? Are you kidding me? What's the cosine of negative 360? 1. 1 to the 8th is 1. The cosine of 360 negative is 1. What's the sine of 360? Are you kidding me that this to the 8th power is 1? I guarantee the FOILer would make a mistake when they FOIL 7 times at some point and not end up getting one, but it would be if you FOILed right. And you go through that whole long process, and I just got that done in a minute. Are you kidding me? Do not write this down. The next one in honors last year, I did extrapolate, and I remember the extrapolation didn't go so hot either. This, it just didn't do what an extrapolation should do, which make you feel better about the formula you're dealing with. So I'm just going to shove this one in your face, and you're just going to have to remember how this works. The way I'm just going to shove this at you here, though, is it's related to this. How this gets done. It's not really related to it, but the math that we have to do. Do you remember this question? Sine of 3 theta equals a half. Yeah. I'm going to throw a computer. Sine of what angle measure equals a half? 30. Okay, but what did you do? What'd you do? You put 3 theta equals 30. And then there was also 150. You had to worry about the other quadrants. Let's just deal with 30. But wait. What else did I have to do? Like, it wasn't just that 3 theta equaled 30 and I had to solve for that. What did I have to do because there was more answers between 0 and 360 that worked? Add what? 360. And then do what? Add another 360 because the 30 degrees should actually have 3 answers come from it, right? Remember that? So 360 plus 390 is still, 750? Never was good at math. And then you divided all these by 3. And the reason this happened was, what's 750 divided by 3? a number between 0 and 360, right? Is that 250, right? Okay, so it's behind the scenes that math that we're going to do for this. Okay, and then I'm going to tell you when we get to the next example, you'll really see the value of this. Well, a little bit, as far as how you value math in general. Find all the cube roots of this. I really should have reversed these, but I'm going in the order of the book. All right, now this is the second concept. I'm going to use two different applications of the second concept. Okay, so here's what you do. Now here's the formula that they say, and this down here is kind of it was hard even for the students last year that had an honors to analyze this and get this figured out. This is why I want to do the brass tacks of this. Okay, so this is already in SIS format, and then my other example is not. So how do I find the cube roots of this? What I have to do is take the cube root of this. That's what they're asking. So that's what the direction said in a way. Okay, so here's how it happens. By the way, what's R? What's R? 1. So what you do is this. And again, this will be more solidified when we do the second set of examples. There are 3 cube roots for every single number. When I ask for the fourth roots of any number, there are 4 fourth roots of a number. When I ask for the blank roots of a number, how many roots are there for that number? Whatever the blank is. And that's what you're going to find out when we're actually solving an equation. All right? And that's where it's really going to be powerful if you care about math. Okay, so the cube roots, this is what you do. It's related to that last rule I just showed you. You take the cube root of R, and you take 1/3 of the angle measure to start off. Okay? So you divide by 3. Instead of when I raise it to the third power, I multiply it by 3, right? So now this is when I divide by 3. But wait, how many answers are there supposed to be? How many cube roots are there supposed to be? 3. So here's another one. And this is why I gave you that one little thing that I did. Take 90 and add 360 to it. What is that? 450. Then do what to that? Divide it by 3. But how many cube roots are there supposed to be? 3. So I need one more. Take 450 and add 360. 810. And divide that by 3. All right? Okay, now, look at what it says up here. I'm going to go against that. It says, I missed again. Leave answers in trig form. So you're actually done when we write this down, but I'm going to do extra. Okay, what's 30? I said it. What's a cube root of 1, by the way? 1 is 30, right? And then what's this next one? 1 is what? 150? Good. And then what's this next one? 1 is 270. Okay, it did work out right. Okay, and by the way, you're done. But I'm going to go further. I'm going to make you understand this even further. Okay? What I'm going to do is I'm going to turn these all into rectangular, and I'm going to go to my calculator and prove what we just did. But before I do that, I'm going to turn this into a rectangular. It's very simple. No, you don't have to. It says that's the answer. But I want your brain ready for this. This is where you're going to get a feel of appreciation for the math. I don't know. What's the cosine of 90? 0. What's the sine of 90? So this is 1i. What we just found is the cube roots of I. We found the numbers when cubed equal I. That's what we found. So now what I'm going to do is I'm going to go to this. I'm going to turn this into rectangular, and then I'm going to cube it. And then what happens when I cube it? What should I get? I. Me? All right. What's the cosine of 30? I swear to dog if you don't know this. Root 3 over 2 plus, what's the sine of 30? 1/2. So this cubed should equal I. That's what you found. I'm going to the calculator now. Ooh. Clear? Last hour I did the fraction button. I don't really need to, but I'm going to anyway. And I'm going to type this. Okay, I know what I'll do. No. I'll go front. Who's he talking to? Himself. And I do answer my own questions when I talk to myself a lot of times. Sign of crazy. Plus alpha. Isn't this stunning on YouTube? 1 divided by 2. And just to make sure that you understand what just happened here. Wrong! What did I forget? Me? I'll be here all week. All right, second insert. Even better for YouTube. I just did that wrong too. This is great. Oh my goodness. What should I get when I press enter now that I'm done? Boom, shaka. Anyone? Laka. Now, I'm not going to do this for the rest of these, but hey, just for giggles, what's the cosine of 150? What's the cosine of 150? It's negative root 3 over 2, right? What's the sine of 150? It's actually positive 1/2, right? Quadrant 2. This cubed will equal I. Then this is special. What's the cosine of 270? No, what's the cosine of 270 first? 0. What's the sine of 270? Negative 1I. So negative I cubed should also equal I. And I don't know what happened to myself. Last hour I got myself all discombobulated on this. What's a negative times a negative? Positive. What's I times I? I squared times negative I. But wait a minute. What's I squared? Negative 1. What's negative 1 times negative I? I. So I'm again just proving what we just found. We found it. And then if I would have cubed that other one in the middle, I would have got I as well. For blank roots of a number, there exist blank answers. Fill in the blank. Okay, now for this one, we actually have to do our math of turning this into a SIS number, because without it, you really can't. You have to do this little rule, and it works. I'm not going to bore you with those details until the next set of examples. So I think this is pretty familiar. We've seen this one like a billion times. Which way do I go for 2? Right? Which way do I go for negative 2 root 3? Didn't we just have this one? And then what's that? So this is 4 SIS what? What's this angle measure here? It's not 45. This is a 60. Let's just make it 300. Now what we need is the cube roots of this. Okay? And then they did say just leave this in trigonometric form. So the first one is the cube root of 4, SIS 300 divided by 4. Right? But then what do I do? Add 360. That's 660 divided by 4. But then what do we do? SIS, it's getting hard. 960, 1020. And then the last one is the cube root of 4, SIS 1380 divided by 4. And then it says leave it in trig format. So what's 300 divided by 4? 125? 170? 75? I was never good at math. I've told you that number. Hey, by the way, cosine and sine of 75, if I had to turn this into rectangular format, what would I need to use? Calculator. 75 is not a special angle. So if I did make you turn this into rectangular, don't cry. You just have to use your calculator because this is not one of our known angle measures. And then find all the other ones. You can divide. All right? But that's not what you have to do for this. You just had to write it in trig. But if I asked you for the rectangular, it would just require a calculator. All right? All right. We're almost done. I actually feel like we're flying through this. Last hour I even told the story about the kids in the hall. No, it's not the TV show. Does anyone ever hear that show, TV show? Just talk about the bums in this school sometimes. I don't want to get on the rant, though. I did compliment your children if this is a parent watching this. Why are you watching this video, by the way? You're not in my class. It's weird. All right. That's if your parents are watching. Why would they watch these videos? I don't know. Okay. Hey, I got something for you. And you should have had this in your Math 2 class. Or Math 3. Probably Math 2, though. something called the fundamental theorem of algebra. Theorem of algebra. And I'm just going to give it to you real short here. I'm going to use my words to explain this. If I have a polynomial that's highest degree is n, so if it's x to the nth power, there exists exactly n solutions for that polynomial, that equation. Do you ever hear that before? I have an x to the fourth. There are 4 answers for that x to the fourth equation. Never heard of that before? Raise your hand if you have. Okay, a couple. Okay, the rest of you probably did. You just don't remember. Okay, because here's the problem. Here's what you did in Math 2, and I'm not ripping on Math 2. When have I ever done that, right? Okay? In Algebra 2, we did this as well. This is very solvable, as far as you know. How do I solve this equation? I subtract 27, and then I do what? Cube root. And in Math 2, in Algebra 2, in Math 3, in cat, me, yow. Before this chapter, we just wrote this as an answer. What's the answer to the cube root of negative 27, by the way? It's not 3i. It's just, no, it's negative 3. I know you said that. You always do that. What's negative 3 times negative 3? 9. What's 9 times negative 3? This is not an I know. But what's the problem? In Math 2, you circled this answer when there's supposed to be how many answers? 3, not just 1. Right? So now your world's going to be expanded that you can find 3 answers when there's supposed to be 3. And it's actually quite simple. X to the third equals negative 27. By the way, negative 27 is the same as negative 27 plus 0i. Right? Because you got to know how to graph this in order to find out what the SIS number is. Where does negative 27i graph? Negative 27 plus I mean. Right, left, up, down. Which way do I go? Left 27. Nowhere up and down. So what's R? What's theta? What's this angle measure, Chiefs? 180. And now for me to do the cube roots of this, to actually solve for this, I know there are 3 answers. The first answer for x is the cube root of 27. SIS, what do I do to 180? Nope, not yet. What do I do to 180 first? Divide by 3. Then the next answer is the cube root of 27. Now what do I do to 180? Add 360 and then what? Divide by 360, 460, 540. And then I'm going to bore you one more time. Please don't, Mr. S. It's my job. 360 plus 540 is what? 900, right? Now let's look at what they expect for the answers. And then I'll tell you why we're going to go beyond that. Leave the answers in what? Trig form. So your answers are, what's the cube root of 27, by the way? 3, SIS, 60. 3, SIS, 1, 2, 3, 8, 16, 24, 180? Yep. And then 3, SIS, 300. And guess what? Okay, you're done. Move on. But no, listen to me. Okay? Because I'm going to show you something. What's the cosine of 180, everybody? What's the cosine of 180? Negative 1. What's the sine of 180? So negative 1 plus 0i times 3 equals negative 3 in rectangular format. There's the answer you got from Math 2. But here are the other answers. I'll just do this one because I don't want to bore you too much. Like I told you, if you have insomnia at night, this is another reason why I do my YouTube videos. Just put in a YouTube Mr. Samuelis teaching video. You'll be down in 5 seconds. All right. What's the cosine of 60, everybody? Let's put this right here, then we'll distribute the 3. What's the cosine of 60? 1/2. What's the sine of 60? Root 3 over 2i. Then you throw a 3 in. So this is 3/2 plus 3 root 3 over 2i. Watch what I do to prove this. It's going to be very similar to this. Ooh, maybe I could do second entry and just manipulate these fractions. Yeah, I don't think that's going to work out as nice. Taking forever to get over here. All right, how do I get rid of that? Delete. All right, good. So it's 3 over 2. And then I got to get into this numerator. Again, thrilling video time. I'm going to delete that and just press enter. And then what I'm going to do is store this. I'm going to store this in for x. And now watch this. What should happen when I write this expression down? X cubed, get out of that, plus 27. What should I get? 0. Because that's what it means to solve an equation. When I plug in an answer that I'm supposed to have into this, it's supposed to equal whatever's over on the other side. Get ready to get excited. Boom, shaka. Anyone? Laka. So that is an answer in rectangular form, and then whatever this is. By the way, just for giggles, what's the cosine of 300? What's the cosine of 300? It's a positive, and it's a positive what? Half. What's the sine of 300? Negative root 3 over 2, and then you distribute. The only difference, it would be 3 halves minus 3 root 3I over 2. Right, and that would be the other one. Okay, so just 2 more, no more boredom. What do you think I should do first? Starts with an A in number 42. Starts with an A. Add, right. That took forever. Okay, then I had to give the second hour clue. It's the opposite of this. And then they got it. There it is. There's the eraser. Okay, so you add this. Then the next thing is to actually turn this into a SIS number. Where do I go for 8? Right? Where do I go for 8 root 3? Up this time, and then you come back. Wait a minute. 8 root 3. I don't even know what this is. 16. This is equal to 16 SIS. What's the angle measure? 60. And then the directions say leave it in trigonometric form, so I won't bore you. You know, by turning it into rectangular and check the answers. This is how you find them. Okay, so x equals the 4th root of 16. SIS, what do I do to 60? Divided by 4. And then what do I do next? By the way, what's the 4th root of 16? 2. Yeah, I'm going to write that for my next one. SIS, and then 360 plus 60? 420 divided by 4. And so on and so on and so forth. Come on, there we go. Okay, we got all 4 answers written. This 4th root of 16 is 2s. That's why I write this. And then you can do the rest. But I just wanted to ask you this question. If I was annoying, but you are, Mr. S. If I was annoying and I made you write this in rectangular format, what would you have to use? Calculator. You'd have to find the cosine of 15. You'd have to find the sine of 15 and then distribute it 2. Not a big deal. Not hard. Okay, I'm not done. I got one more because I like asking this question. I know. I'm sorry. Hey, back in the Math 2 days, how would I solve this equation? Don't get burned. Okay, what would I have to do to solve this? I'd have to 6th root both sides, but then what is the answer? Plus or minus 1. Okay, then you're all happy, Math 2, and you circled this, and how many answers did you forget? You didn't know about it. Not 5, but 4. Okay, so this one's not bad. Don't cry. 1 plus 0i. Where does this graph? So x to the 6th equals 1 was the question. I just have to put plus 0i so I know where this goes. Where does it go? 0. Right? What's r? 1. So it's 1 SIS 0. I did that last hour. I made it a theta. I don't know why. Okay, then to find all the 6 roots, I'm going to list them like this, and then I'm going to show you where a couple of the answers are in rectangular, but you know, we're just going to do it. So what do? I take the what of 1? 6th root of 1. What is happening with my brain? By the way, what's the 6th root of 1? It's 1. It's not 6. I don't know who just said 6. I don't know. Don't admit it. SIS, what do I do with 0, even though it doesn't matter? Divide it by 6. And then it's the 6th root of 1, SIS, 360 divided by 6. And then it's 6th root of 1, SIS, 720 divided by 6. Then it's the 6 root of 1 is, oh boy, now we're getting tough, 1080? And I'm only going to talk about a couple of them, 3 of them in rectangular format. 1 is, oh boy, 360, 440, 1440, right? And then the last one is 1 is 1800 on the dot. Okay, and then the only ones I'm going to deal with are these in rectangular. I'll put them in green. And then you could do the dividing. You know how to get the answers after this. What's the cosine of 0, though, everybody? What's the cosine of 0? What's the cosine of 0? No! 1. What's the sine of 0? Oops. Times 1. This is 1 in rectangular format. One of the answers, did I erase that? One of the answers that you got in Math 2. Let's go to this one. What's 1080 divided by 6? What's 1080 divided by 6? 180. So what's the cosine of 180? Negative 1. What's the sine of 180? Times 1 gives me negative 1. That's the other answer you got in Math 2. Hooray. But now let me annoy you. What's the cosine of, what's 360 divided by 6? 6? Wake up! What was that answer, by the way? 60. What's the cosine of 60? What's the cosine of 60? 1/2. What's the sine of 60? Root 3 over 2i. Now at this point I could bore you. I could go to the calculator, I could type this in, and then I could raise it to the 6th power, and what would I get? What would I get? 1. That's why it's a solution for this equation. So those are the other 4 that you never got to find in the other class. Okay? All right. I love it.